Is that recording now?
Yeah.
Okay, good.
Okay, so are you ready for our super unit circle introduction? We do the hardest part first. Here we go. Top of your paper says C equals 2 pi r, right? And we said on the other side, we substituted in a 1, okay? Now, the question is, why would we use 1? Why is that important? Well, today we're going to learn about what's called the unit circle. All right? The unit circle has its name because the radius is 1. Also, the unit circle in the coordinate plane has the origin as its center. Does it make sense now why we would call it the unit circle? It's a very special circle. It's the only one of its kind. And whenever anyone says unit circle, this is the one that they are referring to.
Can we write that on one of the circle up in the corner?
You can write on the top. That's fine. Now, here's the idea for what we're going to do. Today we're going to talk about what's called radians. And radians mean this. If you were running on a circular track starting at the point X, running laps in this direction for now, the distance that you run would be the outside of the circle, known as the circumference, correct? So according to this formula right here, if we were using math in terms of pi, if you start at X and run one complete lap, how far did you run? 2 pi, didn't you? If you start at X and run one complete lap, you would run 2 pi? Yes? This is very abstract because we have a lot of variables. We know what pi is, but we're going to keep it not as the decimal, but in terms of pi. Does that make sense? Now, here is where some of you have a huge, huge issue. Let's say we were talking about a pizza. Wouldn't you tell me this is 1 pi?
Yeah.
Okay. I know it's a literal thing for some of you, the way you hear it, but if this is a pizza, this is 1 pi. However, when we're talking about the unit circle, the distance around it is 2 pi. Pi pi. Does that make sense? We're going to use this analogy a lot because what you know about fractions is also going to be different on the unit circle, slightly. All right, any questions with the introduction to radians or why we go 2 pi? That's the first key thing. All right, next thing. Let's look at, what is your first value up top? We have 2 pi, right? Okay, so you should have this on your paper like that. Yes, and you're going around in this direction starting from X. Now, let's see how well you get this. Let's go over here to this point. Let's say you start at X and you run half a lap. In terms of pi, how far did you run?
1 pi.
1 pi. But doesn't it seem like over here that would be half a pi? But it's not. It's 1 pi.
Oh yeah, because if you go round 2, then just divide it and count, so that'd be 1 pi.
Correct. You could take 2 pi, divide by 2, like this, and that gives you the pi value. Exactly right. Okay, now, here comes the fun ones. Up top, start at X, run to there. How far did you run?
Half a pi.
All right, so you're saying literally half of pi, right? I'm going to tell you that that is pi over 2.
Oh, it's the same thing.
It's the same thing. You're taking 1 times pi, kind of like this. 1 times pi, 2 times 1, you get pi over 2. We didn't get to 1/4 yet. We're going to get there. What about down here at the bottom? How far is that you would run?
1 1/2.
1 1/2 pi, right? 1 1/2 pi. Yes? But we don't ever use mixed fractions. What is 1.5 as an improper fraction? 3 over 2 pi, which is 3 pi over 2. Does that make sense?
Yes.
Yes? Okay, now, I'm going to put a little star by this one. Because, what if I wrote it like this? Can you see how it would be 1 pi over 2, 2 pi over 2, 3 pi over 2?
Yeah.
Yes? Keep that in mind. That's going to come up a little bit later. So this is like another way to kind of look at it. I'm putting it in quotes. You're never going to have to translate it to this, but there are some of you that will think like this from now on. Believe it or not. All right, so do you have the top circle completely filled in on the top of your notes?
Yes.
All right, we are now going to move to pi over 4. That's the next one on your list. All right, so I'll erase all this. And we're going to talk about pi over 4. All right, so this is fractions. Where is pi on the unit circle if you had to describe it? Always remember, we're always going to start from a running spot of right here at x. It's where? All the way here on the left. Okay, so here's pi. So according to this, I'm going to take pi and divide it into how many parts? 4. 1, 2, 3, 4. All right. Starting here, if I run, don't I run pi over 4, which is the same thing as 1/4 pi? Okay. Now, do you remember the analogy about the pizza pie?
Yeah, why is pi on instead of all the way around? It's only. Wait, no, never mind.
You got it? Okay, so let's talk about pizza pie. Okay, and I'm specifically saying pizza because if we look at this, didn't you learn that this was a quarter once upon a time?
Yeah.
Do you see how you have to retrain your brain in radians?
It's like, well, just think it's half of that.
Right, but it's just the fact that you're so ingrained from doing fractions using like circular diagrams that some of you will say pi over 4 is here. It's not. It's right here. All right? If I go another quarter, how many pi over 4s is that? 2, and what's 2 divided by 4? 1/2. So this is going to remain pi over 2, the reduced form of 2 pi over 4. What does your next one become? 3 pi over 4. And then this would be what? 4 pi over 4?
Yeah.
Which reduces to just pi. Now, if we divide the bottom up into quarters, okay? This is the first time on our unit circle that we're going to look at the fact that when we go beyond pi, I should always have improper fractions. Did I have that in the circle at the top of your page? What was down here on the circle up above? 3 pi over 2. Improper fraction. So now let's count. 1, 2, 3, 4. How many quarters? 5. 5 pi over 4 is taking us into the next part of the circle. Then I get to 6 pi over 4, which reduces, and then I have what?
3 pi over 2. Oh, wait.
This is 3 pi over 2, and then I have 7 pi over 4, and then I get back to 2 pi because it's 8 pi over 4. Yes, no, maybe.
Yeah. It doesn't.
It's going to take a while.
Like break this and like this.
All right, now, here, yes, Mike.
So we're counting in quarters, but not for the first one?
Yeah, you count.
So the
Where aren't you counting in quarters in the first one?
in the first one, you were counting in this 4 sections, right? This 1, 2. So you only had 4 areas of this.
I had 4 pieces of the circumference for every pi, right? Because I divided pi into 4.
But for the first one, you went over where it's pi over 2, or it was just 3 pi, so that.
Right, but Right, but here's the thing, 1/4, what is 2 pi over 4 reduced? Isn't it this?
Also, counting.
I'm counting it and then I'm reducing my answer. Okay, then this would be 3, can't be reduced. This one would be if I were counting 4 pi over 4s, but that reduces to pi. You got what I'm doing now? Okay, so now we've got our 45s. What did I say? What did I say? I'm gonna see if you're paying attention. What did I say? 45. Do you see anything with 45s up there? No. So now what we're gonna do is I've introduced radians. Now I'm gonna go back to something that you know. Okay? Everybody